Hello, my name is Brent Johnson with Firewise Consultants, and in this section we're going to be focusing on the terminology of common items you're going to hear in the field within the documents you're inspecting to, or as you just talk along or read through the code and work with individuals in the fire stopping industry. So I know many of us have been doing this for a long time. Many of us are brand new. So what I wanted to make sure is we don't overlook anybody. We understand some things that are abbreviations we may hear and how they relate back to us as an inspector or installer, but also just to refresh our memory on some of these common items that are found out there. So you're going to hear me as your presenter throughout this training series if you go through all the different programs, use some of these terminologies. So I want to make sure that before we get too far ahead, that we understand some of the abbreviations we're saying, who they are, who to reach out for if you have questions also. So we went through this training process, and one of my new hires here at Firewise actually went through a whole training series and went through some of the studying and the tests that are out there for inspectors. And I asked him what are some of the things that he struggled with, because he was completely green to the industry, design professional by trade, but now getting into the fire stopping side of things. And I said, hey, what did you struggle with? Well, he said a lot of the literature and trainings and just talking to people out there were over my head. I didn't understand. I don't know what an IOR is or who an AHJ was. And there was no real documentation that helped me understand that. So what I want to do is that hopefully the people that maybe are watching this all throughout the country or world have different abbreviations for different people in your jurisdiction. But what we're trying to do is provide an overall statement or terminology to help you understand who that is, and your local building officials may be different, which is totally fine, and who has what authority. But at least we can understand some of the common terminology we're going to be using throughout this training series. So a couple key ones to remember that you're going to see over and over again, not only said by myself within this training program, but also the ASTM documents that we're going to utilize as a fire stop inspector. Two terminologies that come up over and over again is the AHJ and AA. So the AA is the authorizing authority. And within those ASTM inspection documents, you're going to see that could be the owner's rep, architect, or engineer of record. So somebody usually above me on the design side with a professional, potentially licensed, right, or related to the owner is going to make some decisions. Maybe your qualifications of the inspector, approving documents, even some larger roles, as we're going to learn in the videos for ASTM E2174 and E2393 as they relate to the fire stop inspection. So the AA does do a lot of different roles, but again, the final say, and the person that I always recommend you as a special inspector, installer, contractor, whoever has a question, the answer can start with the AA or the owner or the architect or the engineer. But we have to get the final say by the person who signs off on the building. Who is related to fire in your jurisdiction that comes in and says, yep, all fire elements are acceptable? That would be the authority having jurisdiction. In many areas, that would be your local fire marshal, your building official, or even building inspector, sometimes your city inspector, but many times there is a fire marshal that would oversee that element, that comes in, maybe does a fire pump test or looks at fire alarms, things like that, smoke control. Fire stop is a fire related item that we're focusing on. That person, unfortunately, or not unfortunately, but just may have a lot more on their plate now concerning fire stop that needs to be interpreted to properly let the inspector and installer do their job per these new standards in the code. So from that, I like to point out who that person is and understand hopefully a chain of command to get answers from that individual. To say, okay, where do we need T ratings on our project? Well, the special inspector doesn't make that call. It's a code required item, and there's code exceptions that need to be interpreted and accepted or denied. So I would start potentially by the contractor going to the architect or engineer, then off to that authority having jurisdiction, then back to you as the installing contractor or inspector. So those types of processes need to occur, but we first need to identify who is who and kind of get that chain of command to make sure as the special inspector, we're also not overstepping our boundaries. We're observing and reporting as a third party. In some jurisdictions, you have more responsibility than that. So I don't want to speak too far out of turn, but typically we start the process as a third party. And somebody above us will tell us what our role is. So if the building official or authority having jurisdiction says, Brent, it's all on you. And you want to take on that liability of signing off on things, well, that's on you. But the way the standards are worded, somebody else above you needs to approve documents, make code interpretations, tell you where to inspect, how much to inspect, and that whole process. You can educate them on those documents as we're going to teach you, but it's on them to direct your work to start. So understanding that chain of command is always a good process as a special inspector or installer, because it makes it go much smoother as an entire project to say, oh, problem, and not get in arguments with contractors and inspectors and everybody saying, no, my opinion is this, mine's that. Let's go straight to the source. Let's follow the chain of command. Let's get this ironed out in writing and understand an efficient process for all parties involved. Very simple. So below that, we also see other terminologies. An IOR is something that may not be required in your industry. In some states, there is an inspector of record that oversees large amounts of inspection on the project. So they might do framing or just fire-related items, and they might have a special inspector below them doing fire stop or fireproofing. So the IOR holds a lot of responsibility on a project when there is one. Not all projects require them or states require them, but that's a great starting point. If I do have an inspector of record on my project and I'm a special inspector, that's really where I start. Say, hey, I got some questions. How should we start working on this? What's your interpretation? They usually have the ear of the authority having jurisdiction. So understand who the IOR is if you have one. If the answer is we don't have one, Brent, but we have a building inspector through the city, that maybe is the person above you to start before we get to the fire marshal, or that might be the final person. Each jurisdiction is different. ASTM is the American Society for Testing and Materials. So you're going to hear that term come up a lot, but basically it's an association that is developing standards that are followed by the manufacturers or yourself or the contractors or the code. So ASTM standards may be listed in the International Building Code or your specific building code. Those are standards that are adopted and voted on and developed for years upon years. The example of the fire stop inspection, I believe that the design of ASTM started in 2004. It didn't get in the code till 2012. So it's a committee of industry professionals that works on developing different standards to help buildings, get these standards and ways to do construction properly. UL is a common term that we hear a lot and is assumed as kind of the only UL system. Well, UL is actually a laboratory, underwriter's laboratory. And it is one of many laboratories out there that test Firestop. So, Brent, where's your UL system? Well, that's actually incorrect because there are multiple types of Firestop systems out there, not just UL. Intertech or Southwest Research are a couple examples that you may be presented as an inspector or installer. As long as they meet the code requirements, as far as ASTM and UL testing that's in the code, as we're going to learn, they could be applicable and acceptable laboratories and systems. One step that if ever looks suspect to you or confusing, I always ask the question, number one, there's many labs out there. So Brent could start his own lab to test Firestop as long as I follow the code required ASTM or UL test standards developed for Firestop that are in the code. But my laboratory still needs to be accredited by the state. So not all states may allow Brent's lab, let's say. So UL is maybe the most common one overall for Firestop testing, but it's not the only one. EJ is something we have a whole section on, and it's a challenging area of the fire stopping industry that we at Firewise focus a lot of time on to eliminate EJs, because what they are untested conditions or judgments of field conditions. So when there is not a listed system, a lot of our role is, Brent, what is this? I've never seen it before. Does anybody have a system out there? Well, we research all the different directories, provide recommendations to make modifications to follow a system, or worst case, man, we're stuck with this structural steel support. We can't move it because X, Y, and Z. There's really close systems out there. We develop a judgment with a manufacturer usually, and there's different processes and ways out there that can be done, but usually directly from the Firestop manufacturer. That can be then approved and reviewed, and approved by your authority having jurisdiction. So something I always stress here is you're going to see EJs come up a lot, especially if you're doing your job as an inspector. The term's going to come up. We have to understand the approval process because EJs may not be approved sometimes in your jurisdiction. They are a judgment by the manufacturer who knows their testing and data very, very well, better than anybody. So the manufacturer may produce an EJ, or they may say, nope, sorry, Brent, can't do that one. Good luck. So they also say no. But I, as a special inspector, do not approve the engineering judgment. I want to stress that that is a judgment and needs to be approved by the authority having jurisdiction. So just because we're running out the job, I've got this EJ, here it is, just got it, Brent, let's inspect it, go, go, go. Got to get back on track. I got to put something in my report that clearly states not approved. Someone else got to touch that one. So we will get into that whole separate section. ICC is the International Code Council. You may hear that terminology come up. A lot of us know that because we go through ICC in our other inspection standards like concrete or steel or fireproofing. But ICC develops a lot of different things. They're a code council, and you may hear terminology come up with that. CDs, I call that construction drawings, so like your architectural drawings like we saw in the previous sections are called CDs kind of in short, or construction drawings. IFC is the International Firestop Council. That is a association made up of manufacturers and consultants and industry professionals, laboratories, and contractors that are out there, again, developing training programs that many of you maybe have already been through or studying to take exams from, and out there raising awareness with authority having jurisdictions. The FCIA is, again, another association of industry professionals, a lot of the same people, but also a lot more contractors. So there are professional firestop contractors out there. Some even have additional credentials and qualifications and audits that are done to them. So kind of, again, an industry trade profession that's out there trying to raise awareness, continue education and enforcement in the code, and find ways, again, to help continue to build buildings better in this scope of work. And then specs, we already talked about that earlier, but as a remember, when I say the word spec, that'd be your project specifications. And Firestop does have spec section 07840. It's not a code requirement, but it's a great process to sit down and review before we start a project in any role that you have, especially as a contractor, because you'll find many specific items sometimes called out that differ from job to job in that specs as it relates to Firestop. So a couple key terms, again, that you're going to see over and over again. Well, annular space. That's one of the most imperative steps of a through penetration, is the measurement from the outside diameter of the penetration to the inside diameter of the wall or floor or sleeve, basically where the Firestop goes. It's a step that's often overlooked, but an imperative one is once you learn the test standards of a good focal point of inspection, especially why my personal opinion is doing visual inspection so much, because we can check off so many more boxes as you'll learn in the inspection standard and how to read a system section. But annular space is that distance as shown on the left from the pipe to the barrier itself. Point contact is going to be kind of where that red line is shown, as far as somewhere where the penetration touches the penetration. So this is point contact because it's touching on one side. If it's touching on another side, we have a potential problem, as we'll cover. But we're looking maybe allowed within the system to touch on one side of the barrier. So sometimes drawings, and this is a snapshot of what a section view of a Firestop system shows, may allow point contact in the drawing, may even show some material. So again, we walk through all this in great length and how to read a system and how it relates back to your inspection. But angular space and point contact, key terms you're going to see over and over again within the literature. Additionally, we're going to find backing materials called out. So this does talk about different types of backing materials. Sometimes Firestop requires a backing material. It requires it installed in a certain orientation and compression. All these different elements may be called out in your system. Sometimes it's just optional. It just says, yeah, you can have it if you like. So again, please note that these materials are going to be specific to even sometimes a part number. So just because I'm using mineral wool doesn't mean it's acceptable mineral wool for every installation. So with that, I think we can try to watch a video here. Let's see if it works out for us on how mineral wool is made.
Founded in 1934, the Thermofiber plant in Wabash, Indiana, has been producing world-class fire safety and acoustic insulation materials for over 78 years. In the early days, local limestone was quarried as the primary key ingredient in our mineral wool. Today, smarter, recycled alternative materials are used in the production, saving our precious natural resources. Let's take a look at how our mineral wool is created and processed into the many products of Thermofiber. Our process starts here, in the piles of slag and other rock. The slag is received daily from various local steel manufacturers. Slag is a byproduct of the steel industry that otherwise would be discarded into landfills. Our insulation products contain a minimum of 70% recycled content, and we offer products with up to 90% recycled content. To begin, slag and other types of rocks are lifted through a series of conveyor belts and dropped into large furnaces called cupolas. The cupolas are heated to over 2,600 degrees Fahrenheit by burning coke, a form of coal. These cupola furnaces take several hours to heat. Once they're up to temperature, they will run 24 hours a day for 6 days at a time before they're allowed to cool for cleaning. This allows Thermofiber to produce several thousand tons of finished products every month. Making mineral wool is an energy-intensive process. However, studies were done that showed the amount of energy used to make 1 pound of insulation is saved in the first 30 days that the insulation is installed in a building. Another way to look at this is mineral wool insulation saves 12 times the energy that was used to make it every year and for the life of the structure. Once the slag has reached proper temperature, it will turn to liquid or molten lava. The lava is channeled onto high-speed spinning wheels. These spinners dispense the molten lava in a manner similar to cotton candy. As the molten lava is cast forward, a binder or glue is applied, as it is rapidly air-cooled and collected in a large chamber. The entire process, from slag to final product, is monitored here in the cupola control room. A high-tech series of computers and measuring devices ensure a consistent quality product.
So I like this section, this video. Again, this video is brought to us by Owens Corning Thermofiber. So it's a nice process to show how mineral wool is made. We have a whole separate video and section on mineral wool and its importance and how it relates to Firestop. I like to show it here because it's something that's going to come over and over again in your information and education. A lot of people assume that any mineral wool is acceptable. It says mineral wool, just use any 4 pound, 2 pound, I don't care what it is, just use mineral wool and just throw it in there. Well, sometimes it's way more imperative in installation requirements, how much, how deep, how it's compressed, and even what orientation. And this video is a great example of it actually shows the grains, the material as you saw with cotton candy they used. It kind of binds it together and then it lays on top of itself and then it's compressed down. So many times, not always, like penetrations, not so important, but joints where movement occurs, the orientation of the mineral wool and its grains is imperative. So this is a nice video to kind of show how it's made and then compressed down to different densities. And hopefully that can help you understand further in the training on why the orientation and compression of certain types of fire stop conditions is so important.
The collected fibers form a continuous mat that is moved and layered onto a conveyor by a vertical pendulum conveyor called a lapper. The mineral wool is now run across a series of rollers and into a curing oven where it is slowly heated to 450 degrees to cure the binder and compress the material into the required density and overall thickness. Upon exit of the oven, large saws guided by computers cut the newly cured fiber boards and blankets into various thicknesses, lengths, and widths. These blankets are then stacked, compressed, packaged into bags, and bundled for storage in our warehouse or loaded directly into a semi-trailer for immediate departure. In another part of the factory, a different form of mineral wool is being bundled in large bales. This granulated wool is finer and fluffier, but created in much the same way as the other mineral wool boards and blankets. The difference being that no binder is applied to the fiber. These bales are sent to customers that make a variety of products, including acoustical ceiling tiles, brake shoes, and other niche products. In other parts of the plant, high-temperature industrial products are fabricated and custom mineral wool orders are cut, boxed, and processed for delivery. Some finished goods are stored in our warehouse facility, while others are shipped directly to customers. With dedicated employees and 24-hour operations, demand for quality, fire-resistant mineral wool insulation.
All right, so I think it's a video some of us have seen before, but I think it's imperative, as we're going to learn later, that there are many types of backing materials. I like to show you how it's made because it's such an imperative step of fire protection as it relates to fire stop in many of these systems. And many people aren't even aware of how it's made, what it looks like, and its process. So as you can see, it laid on top of itself, it's compressed down to different densities. So the material, again, can withstand fire for much amount of time, but movement and gases and smoke sometimes need fire stop as a smoke seal or added seal to help the overall system. Backer rod also could be used. I was on a job just yesterday. They had a vertical wall-to-wall joint. All it required was backer rod and non-intumescent sealant. Well, the terminology of intumescent was just used. What is that? Well, as the photo shows, some products expand with heat. So if we take the analogy of a snake we used to have as a kid on the 4th of July, you lit it up and it kind of bubbled up and charred and got bigger and kept growing and growing like the photo shows here. Same thing is used in a lot of intumescent sealants or sprays or whatever the materials are. So again, not all products of Firestop are intumescent. That's a common misconception. So I just said the word spray. There's really no intumescent Firestop spray. You might see intumescent paint where the paint on the steel expands, but typical sprays that are used in Firestop are just more of a smoke seal. Typical sealants used on penetrations may be intumescent, but there are non-intumescent sealants and putties and all kinds of different items that may be acceptable for use in a Firestop assembly. So the product does not need to expand or be intumescent, but it's a key term to remember because sometimes we need an intumescent material, but all Firestop material works differently. Some expand at different ratios, some expand at different percentages, temperatures, all these different elements. So this is a nice video the International Firestop Council developed or got from Hilti that I like to show really what happens when intumescent is done. So intumescent action of a Firestop device. In this case, it's a cast-in device that you see cast in the concrete floor. Again, the device holds no rating. There's a system that allows specific installation requirements. We're just showing you not a real fire test, but just what happens with intumescent expansion of that device. It almost seals up the entire, I think it's about a 4-inch device, and then starts to push off itself and expand outward. So as the material gets hotter, it has to get to a certain temperature to react. Then it starts to expand at different ratios. Some Firestop only expands a couple times its size. This example here is probably 20, 30, 40 times its size. So a lot more expansion, but also may need more heat. Also maybe limited to certain types of penetration. So it all falls back to the system. But intumescent is going to be a key term we keep hearing throughout when we read these systems. A couple other terms that you're going to see over and over again and very important steps to remember is F rating. So the code talks about different test standards, and we're going to have a whole section on this. But the code says these test standards within there, it may say you need an F rating of a certain amount to match the barrier. Please note an F rating is a measurement of time it takes for the fire physically to be seen on the cold side of the barrier. So if we're doing a fire test, fire's on one side of the floor, and we're just standing there, we're waiting for flame to physically be seen through the penetration or joint on the floor above. Then we fail our F rating test in a measurement of time. So we're trying to get 2 hours stoppage or F rating. We need to hold on to it for 2 hours total. Penetrations also have to go what's called through a hose stream test. So we have to pass the fire test and then do it with a hose stream test. Sometimes hose stream tests are not required on certain joints like perimeter containment. So again, we're going to have a whole separate section on this. I'm just kind of touching upon common terminology. We'll teach you more about these terms and what they are and how they relate to the code in future sections. A T rating, again, is a measurement of time it takes for a penetration, in this case, to get to a certain temperature, again, on the floor above or on the cold side of the barrier for a certain amount of time. So it's measured in time, increments of 15 minutes, on how long it takes for that penetration or joint, depends on the application, to get to 325 degrees above room temperature. So penetrations may, by code, sometimes require a T rating of a certain hourly rating. Joints, certain joints, like interior joints, may require always to have a T rating equal to the F rating to get what's called an assembly rating. So a head of wall joint has to, if it's a 2-hour wall, needs to pass the test for 2-hour fire protection and 2-hour temperature transfer protection. So again, some people always associate a T rating only with certain penetrations and floor penetrations and things like that, but the test standard may always require it in different forms. So we'll kind of cover that again in a different section. Hose stream test may be required on certain types of joints, and we'll cover what that is in a little bit. But again, note that it's not to simulate a firefighter's hose. We are simulating the pressurization of a fire to make sure the materials stay intact after the event of a fire or during the event of a fire. So pretty rigorous test, which is why the joint distance and annular space is imperative to be followed per the system, and they're always specific because they have to pass multiple steps of this test itself. Movement does occur in certain tests out there. Cycling is an optional test by the manufacturer for certain types of joints, not penetrations. Yet there is a new test standard for penetrations, but currently in today's code, we do not see movement testing of penetrations, only of joints. We can do a class 1, 2, or 3 movement test. It is done prior to the fire test, and it is typically done for a compression and extension ratio or percentages of movement. There's also shear movement as well for like perimeter containment if the floor goes up and down or the facade goes up and down. So again, an optional test the manufacturer can test for. There's a whole separate test standard we're going to learn about. A couple of ratings you can see on a system is the L rating. Again, an optional test only required by code in certain areas called smoke barriers. It's done separate from the fire test and is measured in 2 different increments: ambient room temperature and 400 degrees Fahrenheit, as in the fires starting in the room. It does not test smoke travel or transfer in the event of a full direct fire. So it's testing how smoke travels on day-to-day operations through a penetration or joint, and then it tests as an elevated temperature in the room starts to occur, how the smoke may transfer through that penetration or joint. So again, optional test, as you're going to find, many systems don't even have the L rating on it. Just like the W rating, many systems don't have. That is not required by code, but it's a test that's optional and done separate from the fire test, where they take 36 inches of standing water within a cylinder, let it sit on top of the fire stop penetration or joint for 72 hours, and come back and see if any water got through the fire stopping material. So a nice added bonus that some contractors, owners might want for areas that might get wet. But remember, it's once the material is fully cured. So the product does not hold the W rating. The product may take days to fully cure, if not weeks. Then I can get a temporary 72-hour here, a test to see if it withstands water. So it's not, fire stopping materials are not meant for long-term exposure to the elements, only temporary. So please remember that. EJs, or engineering judgments, we talked about untested conditions, must be approved by the authority having jurisdiction. But with that, we've already kind of covered it. We're going to have a whole section, separate section on that as well. So from this, hopefully you understood some key terminology that you're going to find out there in the industry. We were able to break it down just generically. And as you're going to find, if you go through the entire training series here on firestoptraining.com, you're going to see all these broken out in much more depth. We're going to relate to the code of the L rating, when it's required, where it's required, how to read it in a system. We'll go through how to do a hose stream test, what it looks like, what are the challenges, all those different elements. So hopefully at least this starting point gets you a good idea of some of the terminology, and there'll be a lot more to learn down the road. Again, my name is Brent Johnson with Firewise Consultants, and thank you for taking the time to watch this video.